In a class of 30 students, exactly 7 have been to Mexico and exactly 11 have been to England. Of these students, 7 have been to both Mexico and England. How many students in this class have not been to Mexico or England? So we can make a little diagram and see what this looks like. So 7 have been to Mexico, 11 have been to England, and 4 have been to both. So I'll call this circle the Mexico circle and this the England. So 4 have been to both, so 4 go in there, this common region. Now 7 have been to Mexico, so this circle has to be 7, but this is already 4, so this is 3. This circle has to have a total of 11, but this is already 4, so this is 7. So that means 3 plus 4 plus 7 is the number that have been to either Mexico or England or both, and that is a total of 14. So of the 30 students, if you subtract those 14, you get 16, and this represents the students that have not been to Mexico or England. So number 9, the answer is B. In the diagram, any club may be moved to any unoccupied space. What is the smallest number of clubs that must be moved so that each row and each column contains 3 clubs? Okay. So I guess we have to fiddle around with this. We have to create a scenario where every column and every row has exactly 3 clubs. I guess I don't know if they have not used the word exactly, but I'm pretty certain that's what they mean. All right. Well, after fiddling around and looking at this, the way it works is that you keep this guy, because that makes that row 3. And this one, that would also qualify. But then these ones and the bottom one don't qualify yet, but this one does. So far I'm okay. And remember, I took out this one, so I'll put a circle around it. I had to take that out in order to make it qualify for both this row and this column. Now let's look at the columns. This one is okay, this one is okay, that one is okay, and that one is okay. The only one that's a problem is this row and this column. So in order to fix that, obviously, the one that I took out, which was this guy, I will put it here. And if I do that, I think my problem is solved for that row and that column. But there's one other row that there's a problem, and that's this one right here. That one, it only has 2 x's. So the one that I had removed from here, which is over here, this guy right here, I gotta put that somewhere to make that row and that column, I should say. And obviously I'm gonna put it here. Yeah, I think that makes everything work. So I took this guy here and I put it here, and I took this one and I put it here. And if that is the case, let's just double check if everything works out. This row is fine, this row, second row is fine, this row is now fine, and the last row is fine. And then the columns, that last column also has 3. So there you go. So the number of moves that I made was 2. So 9, the answer is B. The 17th day of the month is Saturday. The first day of that month was. So let's make a little calendar: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And let's first label the 17th day, which they're saying is a Saturday. And I guess we just count backwards. So 16, 15, 14, like that, 13, and so on. 3, 2, 1. So the first day of the month is a Thursday. So number 8, the answer is D. A class of 30 students was asked what they did on their winter holiday. Winter. So you know it's Canada. 20 students said they went skating. 9 students said they went skiing. I have been skating, but I've never been skiing in my entire life. I know that's very shameful, but that's the truth. Exactly 5 students said that they went skating and went skiing. How many students did not go skating and did not go skiing? Well, we'll draw some diagrams here. Hopefully this will be somewhat accurate. And this is how we're going to do this. So the first circle represents all the people who went skating. Second circle is a little bit smaller. It represents all the people that went skiing, which I hope to do someday. And they tell me that 20 students went skating. So this whole circle, the big one, is 20. And this smaller circle is 9. But 5 students went both skating and skiing. So that 5 goes right here, this common region. That is the region that represents students that went both skating and skiing. Now, the big circle represents skating, and they told me that 20 students went skating. Well, 5 is already here, so that means this region's got to be 15. Okay, so does that make sense? 15 plus 5 is 20, and 20 went skating, and skating is represented by that large circle. In the same way, by the same principle, if skiing is represented by the smaller circle, and 9 students went skiing, and 5 has already been placed there, that means this region is a 4. And I know it's not drawn to scale, well, but you get the idea. So, how many students do we have total here? Well, we got 5 plus 15 plus 4, so that is 24 students that went either skating or skiing or a combination of both. But there's 30 students altogether. So 30 minus 24, which is 6, are the students that did not go skiing and did not go skating and therefore were not represented in that diagram. So number 9, the answer is 6, which is choice B. How many more coins does it take to make $1 using nickels than it takes to make $1 using dimes? Well, $1 divided by 5 cents is 20. So it takes 20 of those nickels to make $1. And then you have $1 divided by 10 cents, and that's 10. So it takes 10 dimes to make $1. So they're saying how many more nickels do you need than dimes in this particular scenario? Well, you need 20 nickels, but you only need 10 dimes, so you need 10 more nickels. So the answer is 10. How many more coins does it take? So number 5, that would be choice B. A fair die with faces numbered 1 through 6 is rolled. The number on the top face is X. Which of the following is most likely? So we have 1, 2, 3, 4, 5, and 6. We have those numbers. Let's go through each of these one at a time. A, greater than 2. Well, there's 4 numbers greater than 2, so that probability is 4 out of 6. B, X equals 4 or 5. Well, there's 4 or 5 is 2 numbers out of the 6, so the probability of that is 2/6. C, X is even. There's 3 numbers that are even, so the probability of an even number is 3 out of 6. D, X is less than 3. Well, there's 2 numbers that are less than 3, so that probability is 2/6. And finally, E, X equals 3. Well, there's only one number that is equal to 3, so it's 1/6. So which one of these is most likely? It is the one that has the highest value, and of these, the highest value is 4/6. And that means the answer choice that is correct is A. For question number 7. A cube has 12 edges as shown. How many edges does a square-based pyramid have? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 edges for that square-based pyramid. Number 2, the answer is C. A perfect square is a whole number whose square root is also a whole number. For example, 144 is a perfect square since its square root is 12. How many perfect squares are there between 20? 2 and 20. So we have 2, and then we have all the numbers until 20. So we want between 2 and 20. So we're just looking at the numbers from 3 to 19 inclusive. Well, perfect squares are like 1 squared, which is 1. It's not in that interval. 2 squared, which is 4, which is in that interval. 3 squared, 9. 4 squared, 16. And then 5 squared would be 25, which is outside of that interval. So there's only 3 perfect squares between 2 and 20. So number 6, the answer is D. In the diagram, the rectangular wire grid contains 15 identical squares. The length of the rectangular grid is 10. What is the length of the wire needed to construct the grid? All right, well, looks like we've got 1, 2, 3, 4 pieces of wire that are 10 units. They don't give us any centimeters or meters, right? So they're just 10 units long. So we got 4 times 10, correct? It's basically these 4 segments that they have drawn horizontally. Now, in terms of vertical, 1, 2, 3, 4, 5, 6 of those. So we've got to figure out plus 6 times something. But what is that something here? Well, they tell you that this is 15 identical squares. So that helps because that means that this 10 is divided evenly. So this is 2, 2, like that in terms of the length. And these are squares, so this has got to be 2, right? And therefore, this is 2, this is 2, this is 2, this is 2. So each of those vertical wires is 6, correct? In terms of its length. So there you go. There's the total number of distance of all the wires. So solving, this is 40 plus 36, and that is 76. So number 9, the answer is E. How many integers between 1 and 60 contain the digit 3 at least once? All right, well, we can make a list pretty quickly. 3, 13, 23, all of the ones that are between 30 and 39, 43, 53, and I think that's it. So how many do we have here? 1, 2, 3, 4, 5, and then all of these guys, that's 10. So we've got 10 plus 5, 15 numbers. So number 8, the answer is D.